Hi, I'm Kristen.
Hi, I'm Eve. And our video demonstrates the principle of conservation of linear momentum.
Momentum is defined as an object's mass times its velocity. If we use Newton's second law in algebra, we can see that F net equals ma. We can manipulate this to show that F equals mass times velocity times 1 over time. Then further, if we divide by time, we can see force times time equals m times v, which is also equal to momentum. When two objects collide, they push on each other with equal and opposite forces for a certain amount of time. The net force on both objects is equal, and the time they act on one another is equal. Therefore, the total momentum of both objects is conserved.
The conservation of momentum can best be observed in elastic collisions, such as a collision between two pool balls. In an elastic collision, none of the momentum is lost. All of the kinetic energy of the first ball will be transferred into the second ball. In this example, the first pool ball will continue to move at a much slower velocity because although it transferred the majority of its momentum into the second pool ball, this was not a perfect system, so not all of the energy was able to reach the second pool ball. We showed with the pool balls that in a collision occurring between two objects of equal masses, the total momentum of the two objects before the collision is equal to the total momentum of the two objects after the collision. That is, the momentum lost by the first object is equal to the momentum gained by the second object.
In situations when the two colliding objects are of unequal masses, the conservation of momentum can be expressed using this equation. In the next demonstration, I will hit a golf ball into a more massive croquet ball. The golf ball will lose some of its momentum and the croquet ball will gain momentum. The golf ball will strike the croquet ball with some initial velocity, and after the collision, the croquet ball and the golf ball will have final velocities that are less than the golf ball's initial velocity. Overall, momentum will be conserved. This equation describes the conservation of momentum. As you can see, mass 1 times the initial velocity of mass 1 minus the final velocity of mass 1 is equal to mass 2 times the final velocity of mass 2 minus the initial velocity of mass 2.
Then, using frame-by-frame video analysis, we managed to find the initial velocity and the final velocity of both the croquet ball and the golf ball and plug them in the equation. And,
as you can see, momentum was conserved.